terms, then the determinant can be expressed as the sum of two or more determinants. Sum of two determinants here. Because there are two elements. I mean, two numbers were added here. Two elements were added here. The first two determinants are the sum of two determinants separately. There are three terms are added. Three terms. Let me take a plus a1 plus a2, b plus b1 plus b2, c plus c1 plus c2. Let me take three terms. Then there will be three determinants. The sum of one determinant is equal to sum of the two determinants if any row or column is having two terms. Okay, each having two terms here in this case. Okay, so in that situation, the determinant can be summed up. There are two different determinants. Sum of the two different determinants is equal to that determinant. If the original determinants, one row is having two terms in each element is expressed in two terms. Okay, of three terms or four terms, whatever is number of terms are there, the same number of determinants will be there. This is sum of that determinant is there. This is how the property number 7 we have put. Now we take property number 8. What does property number 8 say? Let me check it. Now in this case, numerical question would also be taken. Okay, but mostly algebraic terms are taken. Then it is simply done. Numerical are added up. But we can't say that can be expressed also. Now it's property number 8. What I say? Each element of a row or a column of a determinant is multiplied by the same constant and then added to the corresponding elements of some other row or column. With some other row or column, then the value of the determinant remains same. This is what. Now it says each element of a row or column of a determinant is multiplied by a same constant, and then added to the corresponding elements of some other row. Okay, then added to the elements of some other row. Yeah. Then added to the corresponding elements of some other row or column, then the value of determinant remains same. This is what let me talk about. Now it says, let me tell you that this is property number 8. Now it says if each element of a row or column of a determinant is multiplied by the same constant, yeah, and then added to the corresponding elements of some other row or column, right? Then added to the corresponding elements of some other row or column, then value of the determinant, then the value of the determinant remains same. Value of the determinant remains same. This is very interesting. Remains same. All right. Now this is the one of the points here. Now if I take numerical question, so that very easily done solution or proof. it says if each element of a row or a column of determinant is multiplied by the same constant, okay, and then it is added up to another point. When it is added up, each element of the row or column of determinant is multiplied by the same constant and then added to the corresponding elements of some other row, then the value of determinant remains same. Okay, let me take numerical question. Okay, let me take of order 2 by 2 numerical question here. This is 2, 3, 4, 5. No problem. Alright. Now what is the answer of this question? Now if I multiply by each element of one first row by same constant, the value of this. Now that is and the point if each element of a row or column of determinant is multiplied by the same constant and then added to the corresponding elements of some other row. But let me first take what is the value of this determinant. This determinant A is a matrix of order 2. Let me take determinant A is equal to what? 5 to 10 is 10 here minus 12 is minus 1. Now let me take, now it says B, let me take another B matrix which is, now let me multiply this by 2 each, 4, this is 6 here, then it is added to this is 4 plus 4 is 6 plus 5 and this 4 and 5 as it is. What do we see? This is 8. Now let me find determinant value B. This is 8 here. So what we have done, we multiplied by 2 this element and then added to the second row, corresponding elements of second row. This is 4 plus 4 and this okay 11 here. This is 4 and 5. No problem. The value of this is 8 5 40. 40 minus 44. This is 4 here. Okay, so this is minus 4 here. That means it is nothing but 2 into minus 2. It means if this is, there are two conditions here. If this is multiplied by 2, okay, we will multiply by 2, then what is the answer? If I multiply by 2 and add it up to this element, that's the another point. But if I multiply this by 2, it will give us 4 and 6. This is 4 and 5. Now in this case, it is the same value, 2 times it is multiplied. It means we have added with the corresponding elements of the another row, but it is the answer twice of that value, original value. So if I find this answer, this is 4 here. This is 4 5 20 minus 24 again. This is minus 24 minus 4. Sorry. It means the answer remains same. This is condition is here that if each element of a row or column of determinant is multiplied by the same constant. Okay, this is first condition. Then what the determinant value is minus 4 coming, and it remains same if it is added to the corresponding elements after multiplication. This is the second position. Okay, so answer is not minus 2 because we are not to find out original, but after multiplication by 2 by a constant to any each element of one row, then answer find this minus 4 here. We have taken here multiplied by 2. But after multiplication, if it added to each element of another corresponding element of another row or column, in this case row we have added up this 4 plus 4 8 and 11 6 plus 5 11. After, so this point is not of this original one, but after multiplying each element of first row or any one row by a constant value, then what is the answer? Is minus 4. Okay, and after this multiplication, then added to the corresponding elements of another row, then find out what the answer. The same answer is obtained here. This is what condition is. This is not that without multiplication by constant we are calculating the value. But after multiplying every element of a row or a column by a constant value, by same constant value, this is one point. Then what is the value of determinant? -4 we have obtained, and then after multiplication, this is added to the another corresponding elements of another row or column. In this case, row we are taking for row. Then what is the answer? Same answer is there. This is point. Eighth one is if each element of the row or column or determinant is multiplied by the same constant. Okay, then what is the answer? Then answer comes out something, and if it is added to corresponding elements of some other row or column, then the value of determinant remains same. This means there is some sentence missing here. And if every element of any row is multiplied by a constant, then whatever value comes out to be, that value is equivalent. That after multiplication by constant, if it is added up to the corresponding elements of another row or column, then whatever value comes out, that remains same. Is the point. Okay, now ninth question, let me take. Ninth, I mean property. Now property number 9. What does it say? Let me check it. Now property number 9. Okay, now property 9. Ninth property is, it says each element of a row or a column of a determinant is 0. Alright, of a determinant of a row or a column. Then its answer is 0. Undoubtedly, then its value is 0. It says that if each element of a row or column is 0, then the value of the determinant is 0. Then the value of the determinant is 0. This is the question here. It says if each element of a row or column of determinant is multiplied by, and if each element of a row or column of determinant is 0, then its value is 0. That's the point. Now let me take proof here. Proof here. Now if I take, okay, let A is a determinant. Let me take determinant A. This value will be calculated. I'm not taking the first row as 0, 0. Okay, let me take this is A11, A12, A13 of order 3 by 3. Okay, let me take. Now this is 0, 0, 0. Okay, any row. Every element of one row, I'm taking 0, 0. It says if any row is having 0 as its element, and then its value is 0. That is set. Is A31, A32, A33. What's the answer of this? Let me take. It is A11 into 0 into 3, 0 into this. It is 0 minus 0, no problem. Minus sign A11, A12, A12. This row, sorry, this column and this row, first row and second column not considered. Is 0 into this 0 minus 0 into this 0. Alright, this is also 0. What we see here, then plus A13, A13, 0 into this 0, alright, minus 0. Whatever comes out is 0. A1 into 0 is 0, minus 0, plus 0, 0. Answer 0. If any row or column of a determinant, one row or column of determinant is 0, 0 elements, having 0 as its elements, then the value of a determinant is 0. Any example can be taken, either algebraic example or numerical example, doesn't matter. So this 0, 0 is multiplied to every element of that. This is what the property number 9 is. So let me take property number 10. Now property number 10, what does it say? Okay, this is the property 10. Now property number 9. Let me clear this. Sorry. Okay, now property number 10. What does it say? Okay, now property number 10. 10th property is, it says that if A in Aij is a diagonal matrix of order n greater than 2, it says if A is equal to Aij is a diagonal matrix. What is a diagonal matrix? I have defined in matrix algebra. A diagonal matrix of order n. Of order n. Now it must be of order n which is greater or equal to 2. It must be at least 2 only. Then only we can find out the answer. So this order must be of square matrix of order 2 or more. Then it is possible. Then this property follows. Okay, of order 2 and greater or equal to 2. Then its value is then determinant A is equal to A11, A22, yeah, A33 into, this is a multiplication, into, and so on, into ANN. Only diagonal elements are multiplied. The answer will be only, the value of determinant will be multiplication of the diagonal elements, the principal diagonal elements. What is diagonal matrix? Let me define that first. Solution and then proof or proof. Solution here means proof. We have to find out the proof of this. What is diagonal element? Diagonal matrix. Now here, diagonal matrix. Diagonal matrix is defined as, what is diagonal matrix? A matrix. Let me take a square matrix or matrix. A square matrix having diagonal elements, principal diagonal, leading diagonal elements, known as leading diagonal elements. Leading diagonal elements as non-zero. Okay, all diagonal elements are not zero, or it may be zero, or one of them may be zero, but all are not zero. All having leading diagonal elements as non-zero, while non-diagonal elements are zeros, and while non-diagonal elements are at zero and at zero. So non-diagonal elements are zero. That means if there is a determinant, in this case for matrix, let me take the matrix A here. This is A11, this is 0, 0, we take of order 3. This is 0 here. Non-diagonal elements are 0, 0, A22, 0, 0, 0, A33. This is of order 3. Here, this is a diagonal element, diagonal matrix. But diagonal matrix is having only diagonal elements as non-zeros, or one of them is 0, but non-diagonal elements are zeros here. This is what non-diagonal elements are. Maybe taken as what you got triangular elements here. Triangular matrices, left triangular or upper or lower triangular, but in this case both upper and lower triangular are zeros. So, diagonal elements are diagonal matrices having non-diagonal elements as zeros, and only diagonal elements are there. Okay, so let me take this as a diagonal element. Now it can be of nth order. Of n order, it can be a square matrix of order. A square matrix is a diagonal matrix. Diagonal matrix is a square matrix in this case. If A is a diagonal matrix of order n means square matrix it is. which is greater than 2. Then the value of determinant is this. So now we see if the value of determinant, let me find out. Value of determinant, this is the diagonal matrix. Now value of determinant we have to find out. So what the value of determinant in this case? Therefore this is of order 3 here, and we have taken 3 here. Let me take of order 3. With square matrix, that is square diagonal matrix of order 3 is expressed this. This is, let me take, this is A11 0 0 0. This is A22 0 0 0 A33. Now we have to find out the determinant value. The value of the determinant, this determinant, the value of this determinant will be what? A11 into this A22 into A33. Diagonal elements are multiplied, minus this 0 here, then minus 0 into 0 0. Let me write 0 into A03, 0 into A33 is 0, minus 0 into 0 is 0. Alright. Then plus sign 0, 0 to something 0, we can write, but this is 0 0 here, minus 0 into A22 is 0. What we see here? Nothing but A11, A22, A33. This is the value of the determinant of order 3. We see here only diagonal elements are multiplied. This is what A11, A22, A33 up to ANM. Whatever order is there, if n is any number, it can be only diagonal elements are multiplied. Determinant value of this diagonal matrix is only the determinant value is obtained by multiplying the diagonal elements on A11, A22, A33. This is the answer. In case of order 3, if n is 3, then this is the answer. If it is 4, then it will be A44 also. If it is n times, then ANN. This is the answer. So proof. Okay, so this is question on property number 10 we have taken. Let me talk about property number 11. So property number 11, let me talk about. Property number 11. 12 property we have taken. So 11 properties, if A and B are square matrices of the same order, and then determinant of A into B, multiplication of A B is equal to determinant A into determinant B. Let me prove this. This is if A and B are square matrices, or square matrices are square matrices of same order, of the same order, of the same order, right? Then determinant of AB, multiplication of AB is equal to determinant of A into determinant of B, multiplication of determinant of A into determinant of B. That is the point. Now if I just find out, let me take A and B are square matrices, okay, of order 2. Then find out the value. Let me take this is proof here. You can prove it. You can take either algebraic, okay, instance, example here, or instance here, or numerical value. Let's take numerical value. We are finding out proof here. Let me take a matrix of order 2. A matrix of order 2. This is 3. Let me take 5 here. No problem. So what is the value of determinant here? Determinant value is 5 to the 10 minus 3 to the 9. This is 1. No problem. Now determinant, let me take B, another matrix. The same order it says square matrix. Let me take 3, 5, 6 and 7. What is the value of determinant B here? The B here is, okay, multiplication, this is 21 minus 6 factor 30. It is minus 7. sorry, minus 9 here. Sorry, 30 minus 21 is minus 9. Okay, minus 9. What do we see? So this is determinant value of B. Determinant value of B is equal to minus 9. So multiplication of A into B. So multiplication of A into B is nothing but this is 1 into minus 9. That means minus 900. Now if I find out the AB product, and you find the product of AB, what do we see? Therefore AB, let me write here. First AB is, okay, this is multiplication of these two determinants here, or two matrices here. 2, 3, this is 3, 5. Multiplying with these two matrices, let me multiply them by matrix law. 3, 5, 6, 7. Multiplication, then we will find out determinant value, or the determinant of that matrix plus matrix. What is the matrix comes out to be this? This is first row multiplied to first column with second column, 2 elements. This is 2 by 2 order, so 2 by 2 order of the resultant matrix will also come. So this is 2 into 3, 6, 2 into 3 plus 3 into 6. Then this 2 into 5, sorry, second column now, 2 into 5 plus 3 into 7. Then this second row is 3 into 3, 9 plus 5 into 6. Then second column, second column, corresponding elements multiplied, 3 into 5, 3 into 5, 5 into 7. What's the value of this determinant? Sorry, this matrix here. 2, 3 are 6. 6 plus 18. 10 plus second element 21. This is 3 9 is 27 plus 30, and this is 15 plus 7 5 35. Final value comes out to be 18 plus 6 is 24. This is 21 plus 10, 31. This final value is 27 plus 30 is 7, 57. And this is 15 plus 35, 50. 15 plus 35, 50. Now what is the determinant value of this? Therefore this is value AB, multiplication of AB matrix. Now let me find out which value, final value of this is what. So determinant value of AB will be, determinant value of AB is the value of this determinant, which is 24, 31, 57, 50. Let me multiply 24 into 50 minus 57 into 31. 57 into 31. This is 0, 5 for the 20, 0, 2. Have to 10 and 12, 1200. Okay, 1200 here. This is 31 into 7. Let me multiply them. 57. 7 into 1 is 7. Okay, then 7 3 are 21. 5 into 5, 26, 6. Okay, 2 carry this 26 here. 26 and 6 are 2 carry. 57 we are multiplying. 7 into 1 7. 7 is 21, 5 into 5. 21 plus 5, 26, 2 carry. That's 15 and 70. I'm sorry, this question is AB determinant we have calculated. Some mistake is coming. Well, the problem here, question number 11 is having some problem. Something mistake has happened. Let me check. Okay, let me take another question here. This is AB. If A and B are square matrices of the same order, then AB multiplied together and equal to A into B. Okay, or we have to find out determinant A into determinant B multiplied to each other. That is the point. The determinant value of A we have calculated. Let me take other example, because A and B I have just rubbed it, so I'm not remembering them. Let me take them A and B in the example. If A is, let me write A here so that it can be not removed. A is, let me take 3, 2 into 1, 1, 4. Okay, and this is B here, a matrix of order 2, 5, 3, 2, 1. Okay, so this determinant of A is 5, 4, 3, 12 minus 2. 12 minus 2 is 10. And here it is determinant B, 5 1 is 5, minus 6, 13 minus 1. So determinant A into determinant B is equal to, if I multiply these two values, determinant A and determinant B, this is 10 into minus 1, that is minus 10. That is the value here. If I find AB, first AB we have to multiply. This is 3, 2, 1, 4 A, and B is here 5, 3, 2, 1. Let me take this. First row, first column, second column. 3, 5 is 15, and 2 to the 4 plus 4. Combine the mistake and okay, change the answer. So this 3, 5 is 15, 4 to the 4. Okay, this is 3, 3 is 9, 2, 1 is 2. Let me take directly. So first column, second column. Now second row, 1, 5 is 5, 4 to the 8 plus 8, 1, 3 is 3, 4, 1 is 4. This is equal to 15 plus 9 is 19, 15 plus 4 is 19, 9 plus 2 is 11. This is 5 plus 8 is 13, 4 plus 3 is 7. Determinant of this value is, therefore AB determinant. Just multiply this 19 into 7 minus 11 into 13. Goes on to 7 and 63. 63, 6, 3 carry, 3, 6 carry.